Hi guys, my name is Wendy Rodriguez.
Hi, I'm Emelia.
Hi, I'm Celena.
And I am Juliana. So for today's video, we'll talk about what is broken symmetry. So first, let us discuss what is symmetry. So symmetry is a mathematical concept as well as an aesthetic one, and it allows us to classify different types of regular patterns and distinguish between them. Symmetry breaking is a more dynamic idea, describing changes in pattern. So symmetry, according to the American Heritage Dictionary, is an exact correspondence of form and constituent configuration on opposite sides of a dividing line or plane or about a center or an axis. If it is impossible to distinguish between the original and final positions of a moved object, we say it has symmetry. Said another way, an object possesses symmetry if it retains its form or shape after some form of transformation or change.
In 1894, Pierre Curie announced what has come to be known as Curie's principle. The symmetry of effects must be found in their causes. In the same publication, Curie discussed a key feature of what later came to be known as spontaneous symmetry breaking. The phenomena generally do not exhibit the symmetry of the laws that govern them. Philosophers have long been interested in the meaning and status of Curie's principle. Only comparatively recently have they begun to delve into the mysteries of spontaneous mystery breaking. The present paper aims to advance the discussion of both of these twin topics by tracing their interaction in classical physics, ordinary quantum mechanics, and quantum field theory. The features of spontaneous symmetry that are peculiar to quantum field theory have received scant attention in the philosophical literature. These features are highlighted here, along with an explanation of why Curie's principle, though valid in quantum field theory, is nearly vacuous in that context.
Our carbon atom became part of the retina of one of the world's greatest scientists. This was just a few years after the discovery of X-rays. Marie Curie and her husband and research partner Pierre wanted to know how a piece of matter could make it possible to see through skin and even walls.
Spontaneous symmetry breaking is a spontaneous process of symmetry breaking by which a physical system in a symmetric state ends up in an asymmetric state. In particular, it can describe systems where the equations of motion or Lagrangian obey symmetries, but the lowest energy vacuum solution do not exhibit the same symmetry. When the system goes to one of those vacuum solutions, the symmetry is broken for perturbation around the vacuum even though the entire Lagrangian retains that symmetry.
Symmetry breaking is just a principle. But in order for symmetry to break, it has to be present to start with. At first, this would seem to replace one problem of pattern formation with another. Before we can explain the circular rings on the pond, in other words, we have to explain the pond. But there is a crucial difference between the rings and the pond. The symmetry of the pond is so extensive, every point on its surface being equivalent to every other, that we do not recognize it as being a pattern. Instead, we see it as a bland uniformity. It is very easy to explain bland uniformity. It is what happens to systems when there is no reason for their component parts to differ from each other. It is, so to speak, nature's default option. If something is symmetric, its component features are replaceable or interchangeable.